Egypt is drawing a new line across the desert, 2,000 kilometers of high-speed rails engineered to connect the Red Sea to the Mediterranean and Cairo to Upper Egypt, threading more than 60 hubs through hostile sands. But this isn't just the largest railway line ever attempted in the desert. It's a $23 billion gamble, racing to finish before spiraling costs, engineering risks, or the desert itself claim victory. With Siemens and global contractors battling heat, sand, and time, what's really being built beneath the surface? The consequences stretch far beyond transport, and the real stakes are only beginning to emerge. Stretching from the Red Sea's industrial port at Ain Sokhna, Egypt's new high-speed railway draws its first thread straight across the desert, tracing a line that will become the Green Corridor. This flagship route runs northwest, bypassing the sprawl of the new administrative capital, then skirting the edge of Cairo before veering toward the Mediterranean. In just under 660 kilometers, the Green Line links the country's commercial heart to Alexandria, Egypt's historic northern gateway, and then pushes onward to the coastal city of El Alamein. From there, the tracks press even further west, reaching Marsa Matruh on the Libyan border. This isn't just a passenger line, it's a freight and logistics backbone designed to move containers from the Red Sea's ports to the Mediterranean in hours, not days. Parallel to this, the Blue Line carves a much longer arc, over 1,100 kilometers, serving as Egypt's true north-south spine. Starting near Cairo's 6th of October city, the Blue Line plunges deep into Upper Egypt, running south through Luxor's ancient temples and on to Aswan, where the Nile meets the desert. The final stretch pushes even further, ending at Abu Simbel within sight of the Sudanese border. This corridor isn't just about speed, it's about connecting the country's fastest-growing cities, tourist icons, and remote communities that have long been cut off from the capital's economic engine. The third route, the Red Line, is shorter but strategically vital. At about 175 kilometers, it links Kina in Upper Egypt to Safaga port on the Red Sea, with a branch to Hurghada, one of the world's most visited beach resorts. Designed with both passenger and heavy freight in mind, the Red Line turns Egypt's inland cities into direct players in global trade. It gives exporters in Kena and the Nile Valley a straight shot to the docks at Safaga, slashing transport times and opening new markets for everything from minerals to manufactured goods. Each corridor is mapped not just to serve Egypt's biggest cities, but to thread more than 60 hubs, urban centers, industrial zones, and port complexes into a single, electrified network. The green, blue, and red lines intersect at key junctions, forming a lattice that allows for seamless transfers and future expansion. Taken together, these three lines redraw the map of Egyptian mobility. They don't just follow the old Nile axis, they leap across the sand, linking coast to coast, city to city, and port to port. For the engineers at the National Authority for Tunnels, this is less about laying track and more about reimagining the country's entire geography. The result? A new backbone for Egypt, visible from space, engineered to pull the nation and the region into a new era of connection. 60 stations anchor Egypt's high-speed rail spine, each one mapped to maximize reach across city, desert, and port. The network's major nodes aren't just stops, they're new urban engines, built to move millions of people and millions of tons of freight every year. The Green Line alone features 21 stations, stretching from Ain Sokhna's port to the far edge of Marsa Matruh. These aren't simple platforms. At Ain Sokhna, the terminal fuses passenger halls with a sprawling intermodal yard, where containers roll directly from ships to trains. Alexandria's station doubles as a regional hub, feeding local commuter lines and connecting to the city's historic tram grid. Further inland, the new administrative capital station is designed as a multi-level interchange, linking the high-speed corridor to Cairo's metro, bus terminals, and a new wave of smart parking structures. Each major city node is paired with a maintenance depot, ensuring that rolling stock can be serviced without long deadhead runs. Smaller stations along the route serve new industrial parks, satellite suburbs, and logistics zones. Even out in the western desert, stops like Alamein and Marsa Matruh are built with future expansion in mind. Oversized concourses, space for retail, and direct access roads for trucks and shuttle buses. On the Blue Line, the pattern repeats at a bigger scale. Stations at Luxor, Aswan, and Abu Simbel are engineered for both tourists and locals, with wide concourses, climate-controlled waiting areas, and direct bus links to archaeological sites. In Upper Egypt, new stations are sited to draw in towns that have long lacked fast, reliable transport. The Red Line's 3 stations, Kina, Safaga Port, and Hurghada, are designed as freight forwarding giants. Safaga's terminal sits just meters from the docks, with sidings long enough for full mineral trains and customs facilities built in. What sets these stations apart is their role as intermodal hubs. Each one is more than a passenger stop. It's a bridge between rail, road, sea, and city. Siemens and Egypt's National Authority for Tunnels have specified platform heights, signaling, and access layouts to handle both high-speed trains and slower regional services. Ticketing is fully digital, with turnstiles and mobile gates ready for tens of thousands of daily boardings. Behind the scenes, operation centers use real-time data to manage flows, reroute traffic, and deploy maintenance teams when sand or heat threaten to disrupt schedules. The scale is staggering. Over 60 new or reconstructed stations, each one tailored to its local context but built to a common standard. Together, they form the human interface of Egypt's railway revolution, places where journeys begin, goods change hands, and cities grow outward into the desert. For the National Authority for Tunnels architectural teams, it's a chance to redraw not just the map, but the daily routines of millions, from port workers in Ain Sokhna to students in Aswan. These stations are the front doors to a new Egypt, each one a promise that the country's future will be faster, cleaner, and more connected than ever before. Right now, thousands of workers and engineers are pushing the Green Line's backbone through the desert, transforming raw sand into a railway grade that stretches from Ain Sokhna to Alexandria. Massive excavators chew through rock and soil around the clock, while fleets of dump trucks shuttle earth to form embankments and cuttings that will hold the high-speed tracks. Where the route crosses wadis or urban arteries, bridge crews from Orascom and Arab contractors pour concrete for viaducts and overpasses, some spanning hundreds of meters to keep the line level above flood-prone ground. In these stretches, the sand is unforgiving. Site supervisors coordinate teams working double shifts, deploying water trucks to keep dust down and using GPS-guided graders to maintain the razor-straight track bed. At station sites, steel skeletons rise out of the desert, with crews welding beams and assembling vast roof trusses that will shelter future passengers from the sun. The shell of the Ain Sokhna terminal is already visible for kilometers, while Alexandria's new station complex is being fitted out to handle both high-speed arrivals and regional transfers. Each phase of earthworks and bridge construction is a race against the climate. Sandstorms can bury equipment overnight, and heat routinely tops 45 degrees Celsius by midday. To stay on schedule, teams have shifted much of the heavy lifting to the early morning and late evening. In some of the most remote segments, mobile camps supply water, fuel, and rest quarters for hundreds of workers at a time. None of this is visible from the old highways or city centers. But from above, the scale is unmistakable. A new ribbon of infrastructure cuts straight across the landscape, with bridges and station shells marking every major crossing. This is the physical groundwork that every power line, signal tower, and kilometer of track will depend on. Without it, the promise of a high-speed desert railway remains just a line on a map. Power is the lifeblood of Egypt's high-speed rail, and right now, a network of high-capacity substations is coming online across the Green Line. Electrical engineers and grid teams are racing to energize the system, wiring up transformers that can handle relentless desert heat and keep the 25 kilovolt catenary humming from Ain Sokhna all the way to Marsa Matruh. These substations, each rated for up to 50 megavolt amperes, are spaced along the corridor to feed both passenger and freight flows at full tilt, day and night. The first units, especially on the Alexandria to Marsa Matruh stretch, are already live, supplying the juice needed for track testing and early train runs. But electrification is only half the story. Siemens technicians and local specialists are also installing the backbone of safety, the European Train Control System, Level 2. ETCS towers and radio block centers are rising every few kilometers, each one packed with electronics hardened against sand and searing temperatures. These towers talk directly to train sets, relaying speed commands and real-time signals to drivers and control rooms in Cairo and Alexandria. It's a leap beyond Egypt's legacy railways. Now every train's movement is tracked every second by digital eyes. Inside the new control centers, operators monitor the entire corridor through wall-sized displays, watching energy flows, signal status, and train positions in real time. Backup power supplies and redundant fiber links are built in, so a sandstorm or power drop won't bring the network to a halt. Engineers have already run test pulses through the wires, verifying that every section from Ain Sokna to Alexandria can deliver the amperage and signal clarity needed for 230 km per hour. With substations energized and ETCS towers in place, the groundwork is set for the first high-speed train sets to move out of the depots. The transition from concrete and steel to electrified, digitally controlled rail isn't just a technical upgrade. It's the moment Egypt's desert backbone comes alive, ready for the next phase: rolling stock and real-world operations. Egypt's new railway isn't just about laying track, it's about the machines that will actually cross the desert, day in and day out. At the heart of the network is a fleet engineered for the world's harshest conditions. Siemens Mobility is delivering 41 Velaro high-speed train sets, each built to reach 250 km per hour, but expected to run at a steady 230 in daily service. These aren't off-the-shelf models. Every Velaro Egypt comes with reinforced door seals, advanced sand filters, and oversized air conditioners, tested to keep running even when temperatures hit 50 degrees Celsius and sandstorms blast the train's nose and undercarriage. For regional routes, 94 0 electric multiple units will handle commuter and local flows, linking smaller cities and industrial zones to the main network. These trains are designed with the same desert-ready specs: sand-proofed ventilation, impact-resistant paint, and robust electronics that can survive both the summer heat and the salt air along the coast. Freight isn't left behind either. 41 Vectron electric locomotives will haul everything from containers to bulk minerals, their traction motors and cooling systems adapted for relentless dust and long, uninterrupted runs between depots. 8 maintenance depots are mapped across the system, with major centers at Ain Sokna and Alexandria. Here, Siemens fleet managers and Egyptian technicians will work side by side, running a 15-year service contract that covers everything from predictive maintenance to daily filter swaps. Each depot is equipped for rapid cleaning, real-time diagnostics, and emergency repairs, crucial when a sandstorm can bury a siding overnight or when heat pushes components to their limits. For the operators, the goal is simple: keep the trains moving, keep the schedule tight, and prove that a high-speed rail system can thrive in the desert. With this hardware, Egypt isn't just buying trains. It's building a rolling ecosystem, one that's ready for the extremes of North Africa and for millions of journeys yet to come. Egypt's desert railway isn't just a feat of engineering, it's a new economic backbone that rivals the Suez Canal in strategic value. For the first time, containers can move from the Red Sea's ports to the Mediterranean in a single day, bypassing congested highways and slashing journey times for both freight and people. This overland bridge gives Egypt a second port-to-port corridor, one that can handle millions of tons of cargo each year and attract global shipping giants looking for speed and reliability. Tourism stands to gain just as much. With high-speed trains running up to 230 km per hour, trips that once took half a day by bus or car, like Cairo to Luxor or Hurghada, can now be made in a matter of hours. That opens the door to weekend getaways and rapid tourist turnover, letting visitors see the pyramids in the morning and the temples of Luxor by afternoon. Egypt's tourism ministry forecasts a surge in both domestic and foreign visitors, with the rail network set to funnel travelers directly to the country's biggest archaeological sites and beach resorts. The environmental payoff is just as bold. By running fully electric trains across all 2,000 kilometers, Egypt is targeting a 70% reduction in carbon emissions compared to the same flows by car or bus. That's a leap toward cleaner air in cities and a smaller carbon footprint for long-distance travel. Operations and maintenance are in the hands of DB International Operations and El Saudi Electric, pairing German rail expertise with local know-how to keep the system running smoothly. For Egypt, this isn't just about moving goods or people faster, it's about rewriting the country's economic map and setting a new standard for sustainable transport across the region. The price tag for Egypt's desert railway is unlike anything the country has attempted before. At $23 billion for the full program, with 8.1 billion euros tied to the core Siemens contract, the financing structure leans heavily on foreign currency loans underwritten by Germany's Euler Hermes and other export credit agencies. Most of this debt is denominated in euros or dollars, exposing Egypt's treasury to currency swings that can drive up repayment costs overnight. The Ministry of Finance has mapped out a 15 to 20-year repayment window, counting on long grace periods and fixed rates where possible, but the International Monetary Fund remains wary. Their analysts warn that any sharp drop in the Egyptian pound could inflate annual debt service by double digits, especially if project revenues lag behind forecasts. Egyptian officials defend the bet, arguing that new freight and commuter flows will eventually cover operating costs, but acknowledge that, for at least the first decade, most repayments will fall on the state budget. To hedge against overruns, the project is being rolled out in phases, prioritizing the Green Line and its busiest stations to generate early revenue and buy time for slower segments. Still, the risk dashboard is crowded. Global interest rates, inflation, and supply chain shocks have already pushed up costs for imported transformers, signaling hardware and rolling stock. On the ground, engineering teams face their own gauntlet. Sandstorms can halt work for days and bury equipment, as seen near El Alamein in 2023. Power substations must be built to withstand 50-degree heat and corrosive salt air, with every delay threatening the June 2026 opening target. Even with double shifts and accelerated bridge work, the final stretch between Alamein and Marsa Matruh remains behind schedule. For Egypt's planners, the challenge isn't just building a railway, it's managing a high-stakes financial and engineering marathon, where every month counts and every setback ripples through the national balance sheet. Egypt's high-speed rail project stretches over 2,000 kilometers, linking more than 60 stations from the Red Sea to the Mediterranean. Civil works are moving forward on the Green Line, with the first high-speed service targeted for June 2026, according to the National Authority for Tunnels and Siemens. This network will become the world's sixth largest high-speed rail system, designed to cut carbon dioxide emissions by 70% compared to road transport, and to connect key cities, ports, and tourism hubs in record time. Yet, some details remain incomplete, such as the full engineering blueprints for the blue and red lines and final budget allocations. Financial risks and desert engineering challenges are still being addressed by Egyptian authorities and international partners. What's clear from the available documents, Egypt is not just building tracks, but reshaping its national infrastructure for decades to come. The outcome will be measured not only in kilometers or trains, but in the new economic and environmental links forged across the desert.